Hello and welcome to C++ Weekly. I'm your host Jason Turner. I'm available for code reviews, contracting, and on-site training. In this episode, I am going to discuss C++ 20's likely and unlikely attributes and show you a practical application for them in real code that I am currently working on. So it's really, it's not really surprising or confusing what exactly likely and unlikely are. So I'm just going to do a quick test here. So if argc is greater than 5, return 29, otherwise return 42. Now, I am in GCC trunk compiling in C++ 20 mode. I'm going to make this just a little bit bigger over here. And to be totally honest, I don't expect there to be actually any difference for us to observe in this code in the compiled output, but we'll see. I haven't actually done the specific test yet. So in this case, I'm saying I'm comparing argc to 5, and you can see here, compare EDI to 5. That is EDI, the first parameter here. I'm in 64-bit Intel. And then I move 42 into EDX. So it loads 29 and 42 into these two registers, EDX to EAX. Then it does this conditional move. This conditional move is going to say if this comparison was false, then it's going to move EDX into EAX. So then it's going to return 42 or 29 respectively, just however it needs to do that. And this is with O3 enabled. I'm actually kind of curious here. What optimization level do we start to see a difference? We have to go all the way to O0 to see a difference. So this is not going to be almost certainly very useful, but we do have an example lined up that will be. Now the idea is that you can mark a particular branch here as likely or unlikely, and it's just that simple. So I'm going to say that it is unlikely that the argument count is greater than 5, and it is likely that it is not greater than 5, because, I don't know, we're not expecting to pass more than 5 arguments to this program necessarily. So these two things didn't change this code at all. It still moved 42 into EDX, 29 into EAX. It still does the comparison and all that. And we could attempt to make this slightly different. Let's just try. And we can just try to play with this for a moment and see if it generates any different code. We're using IO streams. It's going to make things quite a bit harder to reason about, actually. Actually, let's, change this. So I'm using putString, which is a simple C library function that C++ also has, and that makes it a little bit easier to read the generated code. And again, we're just trying to see if there's any difference here. So we don't really need these things. Now, as an aside, both of these functions are actually in the std namespace now because we're in the C++ world, but no one really does that. I like to, out of correctness sake, and sometimes it might make a difference. All right, so this is our code. We're subtracting 8 from RSP. It's setting up which function to call here and 2 different options, and it's generating 14 instructions. And then it adds back, this is interesting, adds back 8 to RSP. That's the stack pointer. All right, so let's see what happens if anything changes if I change these two. All right, so again, nothing changed. So you're wondering, what in the world is the point of this? So I actually have a more complicated example in mind, and I'm going to switch to it now. This particular example is going to be a little bit harder to read because I had to shrink the fonts down quite a bit to actually get everything to fit on here. But I have this function that returns one of two possible, it has one of two possible cases here. If I have this parameter that is a non-const reference to a vector, and I've got an integer ID that I'm looking up, and I call this findIf. So I need to see if an object with this ID already exists in my collection of objects. And if it doesn't, then I need to add that object and then return a reference to it. If it does, then I need to just return the object that was found with that ID. And I'm using a vector in this case. Now I am telling the compiler that it is unlikely to get to the end and not find this particular object, and that it is likely that the object will in fact already exist in its collection. And I wanted to know if the compiler would do different things with this code. Compiler number 1 does have the useLikely macro defined. Compiler 2 does not. So I'm switching out conditionally what I'm going to be doing here. And I can see that it actually did generate different code. Now, what exactly did it do is going to be very difficult to reason about. We're not going to really try to, but what we can see is that the code on the left has useLikely and the code on the right does not have useLikely. So the code on the left is preferring R8 for these operations instead of RCX. It's swapped around a couple of registers. Why? I'm not entirely sure. But then we also have a more swapping of R8 and RCX through the various comparisons, and then slightly less code generated in some cases here on the right side. Let's see. The right side has one more instruction generated. So yeah, it did do some sort of optimization, swapping registers around, preferring different operations, and it seems to have saved one register move somewhere, perhaps. So what exactly did it do? It should have done something similar to as if we had done a profile guided optimization on this code for the compiler to use its own counts of how many times the function was called and what branches were taken to actually optimize the code based on PGO. So what do we do with that? I have a specific use case. Now it turns out if you had been watching my most recent game episode series here, I got to this code where I have this get joystick by ID and I'm passed in a vector of joysticks and an ID, and this is an SFML identifier for the set of joysticks that exist in the system currently. And I said at one point, oh, this is a good use case for blah, but then I didn't tell you what it was, and now here we are. This is the good use case for it. I am going to say that it is unlikely to encounter a joystick that we have not yet encountered, and it is likely that we will already have this joystick. So we can optimize this tiny little bit of code by giving the compiler just a little bit more information that it needs to make things better. So that is what I did here. I've provided the compiler with just a little bit of extra information. Should you use this on every if-else block? No. Definitely should not. Let the compiler do its thing. But I knew that this is a case where the compiler wouldn't have any idea which version was more or less likely. So I thought I would see what happens if I give it a little hint. Now I haven't benchmarked this code, so I don't know what the actual impact is on it. But there you have it. That is likely and unlikely in a potential real-world use case. So thank you for watching this episode of C++ Weekly. I hope you enjoyed it and learned something new about C++ 20. Be sure to subscribe.